Hello everyone, my name is Jonathan Flores and today I'm going to explain the activity LM75 temperature sensor code explanation. So now I'm going to explain how the Python program works to read temperature data from the LM75 sensor using the Raspberry Pi Pico. At the beginning of the code, we import the required modules, that is pin and I2C, and from the machine library and utime for timing functions. These libraries allow us to configure the communication pins and handle delays in the program. So next, we configure the I2C interface, and in this case, I'm using the I2C channel 0 with the pin GP9 as the clock line and GP8 as the data line. The frequency is set to 100 kHz, which is a standard communication speed for I2C sensors. When we define two constants, the I2C address of the LM75, which is 048, and the register address where the temperature value is at store, which is 00. These values are required to correctly request data from the sensor. After that, we define the function called read LM75. This function is responsible for reading and converting the raw temperature data from the LM75 inside the function that we first read 2 bytes from the temperature register, and the LM75 uses a 9-bit temperature format, so we combine the 2 bytes using a left shift and a bitwise OR operation. In the raw data is assembled, we shift it right by 70 bits to isolate the 9-bit temperature value. Then we check whether the reading represents a negative temperature, and the LM75 uses 2 complement for negative values. So if the sign bit is set when we subtract the 512 to obtain the correct sign number. Finally, we multiply the the raw value by 0.125 because each bit corresponds to 0.125 degrees Celsius, and the function returns this final temperature in Celsius. At the bottom of the code, in the while true loop, we continuously call the read LM75 function once per second, and the measured temperature is printed on the Tony console using a formatted message that shows the result with 2 decimal places. This allows us to monitor the ambient temperature in real time. So now we're going to run our code in the physical sensor. So let's see the results. Okay, so now we have the physical circuit with the Raspberry Pi Pico and the LM75. As you can see, we have the connections with the Raspberry, and as you can see, we can see different measures of temperature. In this case, we have a low temperature because we are in a room with AC, and the temperature is a little low, but as you can see, we have a lot of different measures, usually equal to the other.